Hello everyone, welcome back to my channel. Today let's go over a medium that I solved on my own earlier today. So I was at work, so I didn't have time to record, but I did solve this one on my own, so I'm pretty happy with the technique that I recently learned last month. This one is called Increment Submatrices by One. So you can see that I've tried this for over half a year, and it just shows you when you learn a new technique, you're able to apply it to a lot of new problems. In this case, that's the difference array technique, aka the line sweep algorithm, I think it's called. So let's go over it. So initially, you are given a matrix. You want to return a matrix, but first you want to create rows and columns of the dimension of n. Fill them with zeros. So let's call this A, or let's just call this result, better variable name, 0 times n for I in range n. So that basically creates a 3 by 3 matrix, and we'll call it result, as you can see. So 3 by 3, right? 3 rows, 3 columns in terms of width as well. So now basically what they want you to do is increment each submatrix by 1 every time it's called based on this rule. So basically for each sublist, each matrix in the input, the top left is going to be the top left corner to the bottom right corner. So 1, 1, 2, 2, 2, that's all going to be incremented by 1. 0, 0 to 1, 1. So 0th row and 0th column to first row and first column is also going to be incremented by 1, and then you just want to return that. So it's going to be really slow if you do this in 1 by 1, iterating over every single cell and incrementing it by 1. But using the difference array technique that I learned recently, we can do this much quicker. So for Q and queries, let's call this top left. Let's call this left column. So we're going to get the top left, which is called this row left, row right, and then this is going to be the bottom left, bottom right, or row row, row column, bottom column, and that's going to be Q of 0, Q of 1, Q of 2, and Q of 3. So that lines up, right? Q of 0, Q of 1, Q of 2, and Q of 2, and Q of 3. So now that you know where you want to go, now this, instead of becoming n squared, again, doing another nested loop, we can simply just iterate from I in range. So we have to think about how many rows we're going to go in. So for I in range, RR to BR, Q0 to Q2, because that's how many different rows we have. And then now for the column, or that's how many, vertically we're going to go down by how many. And then to right, that's when we can use the difference array technique. So because we know that Q1 and Q3 is going to be the, looks like, so here you have 0, 0, 1, 1. It'd be great if this is not a square, so it'd be easier. So the start is going to be RC, and the end is going to be BC. So if, and the current row we're trying to increment, so if I is less than results, let's think about this for a second. So for I in range n, let's draw this out. So for each row, from 0, 0, row, column, so row, column, so this is the start row, this is the end row. So start row, end row is going to be, so for I in range, start row is going to be RR, BR plus 1, right? Python goes up to not including this. I made that mistake just a second ago. And we're going to say the current row we're iterating over So from here, for example, it's going to be 1 to 2, it's going to be 0 to 1, the 0th row to the 1th row inclusive. So the current row would be result of I, and we're trying to say, so the start is going to be RR, right? If start is less than, well, results of I of start is always plus equal to 1. And then if the end is going to be BR, let's do this. If BR is plus 1 is less than length of result of I, which is the length of the current row in terms of how wide it is, then result I of BR plus 1 minus equal to 1, right? Because if we have this submatrix, we want to increment this by 20, then we do 20, 0, 0, negative 20. And then you accumulate it, you get 20, 20, 20, 0, right? So incrementing all these plus 20. And then to verify our work, let's print results. So now when we accumulate this, you can see we get 1, 1, 0, 1, 2, 1, 0, 1, 1. So now let's make an answer. And for R in results, answer.append list itertools dot accumulates R. Again, we're just summing up everything, accumulating each row from what we just created, and then we can return answer. So, oh, okay. Did I get something wrong here? Let's see. Okay. So 0, 0 to 1, 1. No, yeah, it is that. Let's call this start row. End row is Q0, Q2, start column, end column is Q1 and Q3. So, okay, so how many columns? Row, if result I so we're looking for this, we're trying to increment like this. For example, result of I is the current row, and then the start row. Oh, okay, so result I start column plus equals to 1 if n column is less than length of result of I, because column is how wide it is, then result I n column plus 1 minus equal to 1. Result I for I in range, start row to end row plus 1. So, oh, there we go. So cool. Yeah, I just have to be careful here because when you're looking at the column, it's actually the width. The row is vertical, the column is horizontal. So you gotta just play around with it a little bit and then apply the difference array technique and then accumulate it. So yeah, it was a little confusing. Hopefully this made sense after all, because again, we're going from, this is going down, so it's going vertically, this loop, and the columns is supposed to go from left to right, like horizontally. That's what this is. So thank you for watching. I know it was a little confusing, and consider subscribing if you found this helpful, and stay tuned for more. Thank you for watching.